let's dive into the next one. Let's get back to our diagram real quick and just talk about where we are. So in the previous video, we made the use case here. Now it's time to make this controller. Then you'll notice we have completed the cycle of events, starting from the author inputting something and then running all the way through to the entities. All right, so let's dive into that. First thing, I want to jump back. I want to just add a little quick something on the end of what the previous video of these repositories or these use cases. So I made this drag tape body. We made this in the last video, but I want to show you how we're adding it to a context. So as you remember, it's a factory created function. So that only needs to be created once at the beginning. And then after that, anybody can use this function, and it's got the repository built into it already. So we don't need to, so we need to generate this function on start, but then we need a way to hand it around. And that's what we call the use case context. So I come down here, and this thing is a bit of a, it's not awesome to look at, but it's handy. So what we're going to do is we're going to add in this this drag, what was it called? Drag tape body. We're going to add that in. And just to keep things a little bit organized, because this thing is hard to read, I try to keep them roughly in alphabetical order. So we're going to do this thing. We're going to do drag, and I'm going to just grab the signature off of this guy. So the output of this is this signature right here. So we're going to add right here, and we're going to define this. This is this is an interface. We're defining the use case context here, like this. And we don't have a vector 3 in here. That's kind of odd. Vector 3 from entities. Okay, be a bit of a pain. There we go. All right, so now we've got it defined in our use case context, and then below we have a function to make the use case context on start. It makes this just a handy thing. So what we want to do is call. Let's find about where we're going to have a constant drag tape body, and that's going to be equal to a make drag tape body, and we're going to pass in our tape measure. Oh, well, I think up here we spread the entities to make it easy. There we go. So now we've made our function, and let's return it in our context. So, oops, something is still not right. Semicolon. What's going on here? Oh, it's got to return something. There we go. All right, so that's how we make our context. Now it's available to everybody out there. So there's that. All right, let's get into our controllers. So remember, controllers pick up use case from the user. Now, let's do some more sketching to kind of describe what the math looks like behind this guy. So again, let's get back to our sketch pad here, and let's get to a new sheet. So we already talked about this in 2D in the entity space. Now we're going to talk about this in the 3D space. So let me get my marker out here. And now we're back into 3D. So we got this guy coming off, and here is our tape body here, and we got our point, and we've got our point out here. Now, this is in 3D space, so it's a little more complicated to draw and to think about. But here's what's going on. In the scene, I've got a mathematical plane. So in the same plane that everything is lying in this 3D world, we've got this plane that looks, we're just going to draw it like, this is I refer to it as our work plane. So this is our work plane, and I'm just going to put the coordinates right here. So here is our work plane. And you'll notice, well, the center of the work plane is aligned at the origin of the world in our Babylon world. So it's at 0, 0, 0. Everything, well, it's at 0, 0, 0. It is not in that, it's not like scaled with that transform we have in there that turns the metric, turns meters into inches. So everything we talk about with respect to this plane is in meters and has to be converted to inches before we can pass it in. Okay, so it's set up to where the work plane, the normal, is up, is in the Babylon world. So it's pointed up in the positive Y. And then the X is aligned. X is X and Z actually. Well, no, yeah. There's no Z. X is aligned with world X, and Z is aligned, Y I should say, it's a plane, so Y is with world Z. Okay, so what does that really mean? That means, so this is the world coordinate system, we'll say. This is Babylon origin. This is X, this is Z, and this is Y. That means our plane is right here next to it. So this is our plane origin, where this is X and this is Y, and then this is in for our plane normal. Okay, so that's how this scene is organized. So now in our world we've got a mouse floating around. We got a mouse ray coming in. So the mouse ray, what it's doing is it's coming from the point of the camera, which is essentially, think about it as the center of your forehead. It's passing through the screen at your mouse position and casting a ray into the scene and colliding with this plane. So let's say that plane comes in, that ray comes in like this. So kind of at an angle down. And we're going to call that the intersection. So this is our mouse ray. And this is going to be hit 0, right? And this is a vector 3. It's going to happen in the real world, in the metric world too, in the world coordinates. And that's going to be X, Y, Z. Now, you're going to, so in this example, the mouse is coming in. It's pointing at the body, which is great because that's what we want to pick on to know we're going to drag it. You're going to press. We're going to see if we hit that. If we hit this body or a body of a transform or of a tape measure, we're going to be like, sweet, we got the thing. And then we're going to expect them to drag, right? And so this is going to be the mouse ray 2. It's going to, they've drug it over to here. And this is the point where it hits that, the plane is right here. And so this is pick, or hit 2. Jeez, let me clean that up a little bit. Hit 2. And it's also, you know, a 3D vector, X, Y, Z, right? So now what we can do is we can calculate this drag vector. This is our drag vector that we need to pass. So when we hit this guy, we can get the ID of it. So that's one thing we need. We need two things. We need the ID and we need the drag vector in inches, not in the metric. So here's our drag vector. So our drag vector is going to be equal to hit 2, I should call it hit 1, minus hit 1. Hit 0. Hit 0. Let's convert these to, this should be hit 1, and this should be hit 1. So this is hit 1, and this is hit 1. So that's our drag vector. But this is also in meters. So we need to convert it to inches. Easy peasy. Fortunately, our units are all lined up, so we don't have to like transform it or anything. So we should be good to go. So that's what we're going to get into. We're going to get a mouse press. We're going to do some conditional checks, and then we're going to do a drag. And when every time we drag, we're going to see how far we've dragged. We've drug. We're going to calculate that drag vector. We're going to convert it to inches. Then we're going to send that to the use case. That's all we got to do. So some things to note about this. One, even though we're talking about mouse presses and stuff like this, a touch is going to be the same idea. It's going to be a different controller because you'll see we're going to be using like on press, on drag. A touch is on touch and on drag. So it's slightly different there. Alternatively, or additionally, at some point we're going to be doing a Z-Space stylus, which is another ray. It's still the same thing. It's a ray being cast and hitting that tape measure box. We're going to pick up a button press with that ray, or with the stylus, and then you're going to drag, and we're going to collide again when you moved that ray and pick a new spot. And again, all this is the same. So, but that's a different controller. But they all kind of have the same idea behind them. All right, I think we'll stop this video and we will jump into actually building this controller in the next one.